Mr. Robert. He's running a consultancy company based out of Germany, Austria. He lives in Austria, and he's consulting all over the world in any of the tire recycling fields. He has a representative who's running Franklin out here, is handling his India operations. So that's just an introduction. Robert, for you.
Thank you. Thank you very much, Vishal. Nice to see all of you. Do you see my presentation on screen? Can I get some feedback if you see my presentation?
Yeah, we can see you.
Okay, very good.
Presentation.
Okay, thank you very much. Thank you very much for the invitation. I would like to send you warm greetings from Vienna, Austria right now. I hope very much that next time I will be able to physically attend. It is a high priority to me to see you in person, hopefully next time. My short presentation should not last longer than 10 minutes. It should give you a snapshot about the European management of end-of-life tires, inform about the existing management systems in Europe, the status quo, the trends, and how to reach more circularity in end-of-life tire recycling. Vish has already informed you that my company is specialized exclusively on tire recycling and pyrolysis. I started the company in 1999 already, so 23 years ago. We're headquartered in Vienna, Austria. We have a very global reach. Franklin is representing us in India, but we have also colleagues in Morocco, in Bahrain, Canada, United States, and Argentina. Our typical clients start from new project initiators to recycling associations and governments. We do market research, technical due diligence, investor search, and all other aspects necessary to run a successful tire recycling pyrolysis business. I'm very proud to tell you that we also publish a monthly newsletter where we have 22,000 subscribers interested to read about tire recycling pyrolysis on a global basis. And after this presentation is shared, you're welcome to click on this link to subscribe free of charge, and you will get information about the global happenings in tire recycling and pyrolysis. So why ELT management systems are very important, and what did it really mean in Europe? Approximately 3 million tons of ELTs are generated in the European Union at this given moment. We have actually no specific EU applications, EU-wide obligations for recovery of used tires, and each member state is free to choose its management system. However, there are 3 systems which establish themselves. One is the tax system, the free market system, and the EPR system, the third one. EPR, as you can see with the green countries shown in the graph, covers more than 60% of annual ELT arisings in Europe. Free market system follows with 38%, and the tax system with 2%. But besides the management systems, there's other important measurements which lead to recovering almost all tires also in Europe over the past 20 years. First of all, there was a ban on landfilling. There was a landfill directive imposed in 2006 by the European Union. And very important, and I will repeat that 2-3 times during this presentation, the implementation of the waste hierarchy, which has directly contributed to investments into modern tire sorting, tire collection, and tire recycling facilities. And when we look at the Lansing's ladder as an example for the waste hierarchy, we see landfilling at the very bottom, incineration as a slightly better way, energy recovery as a slightly better way, recycling as an even better way, but reuse and reduce as the best possible options in the waste hierarchy. And this is where all our industry participants should aim to go for. The success of this approach is measured by a high recovery rate of 92% on average, but also even 100% in many countries. On a timeline, what does this mean? In 1996, 49% of tires were still landfilled. Today, we only have about 8% left, which are landfilled or unknown. And one more example, let's take material recovery. In 1996, it was just 11% of the total volume. Today, we're talking about 46% are going through material recovery. Next slide, 1 second. So in Europe, mechanical recyclers process approximately 150 million tons annually, or 1 tire for every 3 EU citizens. About 1.9 million tons of tires were treated through material recovery, of which 75% go into granulation. And the management of ELTs is completed with a 1.4 million tons of tires that went through energy recovery, mainly in cement kilns. That is a very important number. So we can say that in Europe, we still have a potential of 1.4 million tons of ELTs on a yearly basis, for which we can, or we have to find a better and more meaningful way of recovery. Just for waste to energy or tires to energy, that's not the best way we should aim for. Whereas pyrolysis on the European landscape, opposite to India, where it's a very dominant field, in Europe, it's almost negligible. It's less than 1% of tires go into pyrolysis operations at this given moment. But we will see later the reasons why this will drastically change. What are the main ELT applications in the EU which have established themselves over the past 20 years? And how do they contribute to recycling in the waste hierarchy? And what is needed to move even a step further in the ladder to more reuse and more circularity? We see here an overview about the most dominant applications, what happens to ELTs in Europe. As we can see here, and I will turn on the laser pointer again, we have about today 37% going into artificial turf pitches as infill material, which was 48% in 2010. So actually there was a drop in numbers in the past 7 to 10 years. Molded objects increased from 19 to 22%. So there's a moderate increase. In situ applications remained at 18%. We are talking about athletic tracks, children playgrounds. So this are the majority of applications, and what we can see that there's not much movement going on. So we will not see, let's say, a big upswing of these applications taking more share away, for example, from the energy recovery number of 1.4 million tons I was talking in the previous slide. And also very important when we refer back to the Lansing's letter, these applications are covering the recycling part of the waste hierarchy, not necessarily the reuse part. Of course, partially they do, but mostly it's recycling. It's much better than energy recovery, incineration, landfill. But just recycling is not enough to reduce CO2 emissions and save the planet. So what is the next potential technology to climb up the ladder and get more into reuse, end of life tire material into meaningful products to become a real circular process in the future? Tire pyrolysis, in our opinion, is a possibility, and I will show you again later the reasons why we believe that will change the landscape. So what is the status quo in the tire pyrolysis industry at the moment? I have here an overview about Europe, Asia Pacific and North America. We call it the quiet before the storm. In Europe and North America, it's still in its infancy, and that's mostly because of very strong environmental regulations, and also because of the offtake markets, which have not been as ready as in India, for example. Certainly, the Asia Pacific region leads in volume. The volumes given here are certainly different to what we have been seeing in previous slides during this conference, but the numbers in our database is based on on research we carry out, market research we carry out globally, where we interview companies all around the globe about their existing pyrolysis facilities. And this is the numbers we currently have in our database. It's still already quite large numbers for the Asia Pacific. The volume, however, is largely processed under poor environmental and operational controls, but also it is improving due to the rapidly changing environmental policies in India and the rest of Asia. And we must not forget, when we talk about also tire pyrolysis industry in Europe and North America, you can actually buy a plant for $1 million, or you can buy a same capacity plant for $30 million, which complies to all the environmental requirements and is state of the art when you run such a plant in Europe or North America. So also, of course, the high capex needed time to have the industry grow and be prepared to accept such large investments in Europe and North America to get a sensible return on investment. You will see here that I differentiated between total RCP production capacity and RCP2 production capacity. RCP2 capacity, RCP2 quality is a RCP quality which also goes through refining, which is milling or pelletizing, and has a low volatile content. So a higher quality carbon black, which can be sold into the tire industry, which can be sold to wetsuit applications or master batch applications. Something where India for sure has still a large potential to improve the qualities. Why capacities will drastically grow? 4 reasons. Opposite to India, in Europe or in the US, there is already a high demand for tire-derived oil for circular applications. And therefore, I'm not talking about burning it into a cement kiln or using it into road application, but oil is a substrate for producing materials, not for waste to energy. BASF in Germany leads the way. They source tire-derived oil from renowned European tire pyrolysis plants like ReOil, New Energy, Pyrum, and their demand is about 100,000 tons of TDO per year as soon as these plants are become available. And BASF goes as far as also investing money into the industry. They provide loans for new pyrolysis plants in order to get these 100,000 tons of tire-derived oil per year, which they feed into their chemical crackers, substitute fossil fuels. And interestingly, what BASF clearly states, products made from pyrolysis oil have the exact same properties as products manufactured with primary fossil resources. Very important. Another example is the RECYKAL project, where Michelin as a major tire manufacturer and Orion as a major virgin carbon black manufacturer is involved. This project aims to increase up to 10 times the secondary raw material rate into a new tire, to recycle at least 50% of the European ELTs. So finding a solution for the 1.4 million tons of tires which are currently still being incinerated in cement kilns. And they aim to decrease CO2 emissions by at least 50%. So in this initiative targets 700,000 tons of TDO per year. Again, with this information, investors become confident and spend also $20–30 million into a major tire pyrolysis plant in Europe or the United States. Reason number 2, rising RCP prices. RCP pricing, of course, depends on quality and consistency. The most important price enabler is tight product consistency through tire feedstock and process control. And when you see these prices, please don't refer to these prices for the Indian market. This is clearly for the European Union or for the American market, where we're talking about a high quality RCP, which is of low volatile content, which is milled, which is pelletized. And we predict that sooner or later, these RECYKAL carbon black prices will decouple also from virgin carbon black prices. Please recognize that the feedstock for a recovered carbon black is not oil like for virgin carbon black, it's a tire, and markets for the supply of tires is much more predictable than a crude oil market. Number 3, tire pyrolysis is proven to protect the environment and save resources. Life cycle assessments have been carried out. As we are progressing already past the 10 minutes, I'm allowed to speak. I will move on very quickly, but please have a look here. A life cycle analysis has compared ambient grinding, dynamic devulcanization, pyrolysis, and illegal tire oil extraction. And we will have above the red line the negative impacts to environment, and below the red line the positive impacts on the environment. So all of these 4 means of recycling have a positive aspect, but only one has hardly any negative impacts, and this is pyrolysis. If you do it the right way, of course, if you do it state of the art, if you do not necessarily, as we heard in previous applications, use electricity or external gas to heat the process, there's enough gas which can power the reactor or process temperatures. So if you do it right, pyrolysis is definitely the best way from an environmental perspective. And finally, the 4th one, big players are already now in the game. These are representatives of Western European or North American producers of operators of pyrolysis plants. And as you can see, the big names are now already in industry. They have strong ties with these companies. They are either shareholders, they have exclusive offtake agreements. So there's a lot of momentum in the industry where also these big players are proactively going to the markets and announce they want recovered carbon black, they want TDO. It's a material for the future to make tires more sustainable and more circular. So to underline what I was just saying, in Europe, what's coming up now, we have at the moment about 19 operating plants in Europe altogether with a nominal nameplate capacity of 230,000 tons per year. We have currently 12 companies under construction in Europe, which add another 300,000 tons of ELT treatment per year, and another 29 companies in planning, which would add another 400, not maybe even 500,000 tons in the next 3 to 5 years to the market. Can India learn anything from Europe? I mean, the markets are very difficult to compare. Some concluding thoughts. EPR schemes definitely helped a lot to ensure close to zero landfilling in Europe, but that you already achieved in India anyways. But the controlled monitoring of ELTs formed the basis for various new industries. If you have more control, you have more security for investors, you have more money in the market. So that is very important to grow and stabilize an industry. So you need a stable government policy, which is the basis for much needed large-scale investments in state-of-the-art technologies. Environmentally sound operation of plants is a must. I think that is something where there's a lot of potential in India. And what is a must in Europe and in the US, every pyrolysis company or even every material recycling and tire recycling company, they need to be certified. Clients of ELT treatment facilities demand certifications confirming sustainability and circularity of the products, ISCC+, Ecoloop, Cradle to Cradle, ISO certifications. That is very important because regular independent audits to receive such certifications ensure the total quality management of these plants and product consistency. And product consistency guarantees happy customers paying a better price. And very important, I think that is opposite to India, the TDO in Europe or in the US is not any longer regarded as a fuel to substitute furnace oil, but as a feedstock to the chemical industry and the virgin carbon black industry. So today, my last 2 slides, that today the tire value chain, unfortunately, still is a one-way street. chemical upcycling, we believe, is the missing link for circular ELT material flow. Of course, it includes also devulcanization and other methods, but in terms of potential volume, we are pretty sure that chemical recycling, chemical upcycling pyrolysis is the missing link to really truly turn the industry into a very circular product where you can manufacture a tire, disintegrate the tire, use the tire pyrolysis oil to produce chemicals again, to produce polyethylene, polypropylene again, to use the tire derived oil to produce virgin carbon black again, which is used in tires, and then the newly made tires can be recycled again in a chemical upcycling way and can be reused again and again. Thank you very much for listening to me, and hope to see you soon next time in person.